Welcome to This Explainer. Today, we're tackling what looks like a super simple math problem on the surface, but actually, it functions exactly like a classic locked room detective mystery. We're going to use set theory and some basic logic to crack a case of missing numbers. And I promise you, by the end of this, you are going to view data puzzles in a completely different way. I absolutely love how structured logic can take a situation that seems literally impossible and make it perfectly crystal clear. So grab your mental magnifying glass and let's unravel the football and cricket Venn diagram mystery together. Okay, let's dive right into this. Here is the crazy paradox staring us right in the face. We have a class of exactly 29 students. We're told that 20 of them play football and 18 of them play cricket. But wait a minute. If you take 20 and 18, how on earth do they fit inside a hard limit of 29? It immediately feels like we're breaking the laws of physics here, or at least basic arithmetic, right? We simply have way too many players and not enough students.
Section 1. The crime scene. What we know so far.
All right, let's look at the cold, hard facts laid out straight from our source material. In set theory, we call the absolute total limit of our data the universe. And here, our universe is the total class size, which is strictly 29 students. Nobody else is walking through that classroom door. Inside that universe, we have our football group, which we'll call F, totaling 20 students. Then we have our cricket group, C, with 18 students. So those are our established, undisputed parameters. But, when we place these facts side by side, the cognitive dissonance really hits you. On one hand, our absolute universe of total students is 29. On the other hand, the basic sum of our football and cricket players is 38. That is an excess of 9 students who just, poof, seemingly materialized out of thin air. We have an undeniable discrepancy here. 38 absolutely cannot equal 29. Something is hiding in the data, and it's our job to find it. Section 2. Decoding the hidden clue, finding the missing link. And boom, here is our smoking gun. The original problem states, each student plays at least one sport. Now, this isn't just throwaway filler text. It is a strict, binding mathematical rule that is perfectly disguised as a casual English sentence. It tells us something incredibly specific about the behavior of our universe of 29 students. So what does it actually mean? Well, it translates perfectly to a giant zero. 0 students play neither sport. There is literally no one sitting on the sidelines just reading a book. Every single person in that 29 student universe is either in the football group, the cricket group, or maybe both. The union of our two sports covers the entire class, leaving absolutely 0 leftovers. This right here is a massive breakthrough for our investigation. Section 3. The tool. Introducing the union formula. Now, what's really interesting here is how elegantly the union formula handles our problem. It states that the total number of students in both groups combined, the union, equals the number of football players plus the number of cricket players minus the overlap. The overlap is the intersection, the students who play both sports. Why do we subtract it? Well, because if you just add the 20 football players and the 18 cricket players together, you are double counting the incredibly athletic kids who play both. They get counted once for football and then again for cricket. This formula helps us isolate that overlap so we only count those kids once. Section 4. Solving the case, plugging in the evidence. Okay, here's the deeply satisfying part. We take our union formula and just plug in the knowns. The total union is 29. Remember, because 0 students play neither sport, the union is the entire class. So 29 equals 20 football players plus 18 cricket players minus our unknown overlap, which we're going to call X. Step 2, we just do a little basic algebra to rearrange the furniture. We pull X to one side, meaning X equals 20 plus 18 minus 29. And step 3 reveals our culprit, X equals 9. 9 students are playing both football and cricket. These 9 students were the ones causing our bizarre 38 to 29 discrepancy because they were hiding in both groups the whole time. Section 5. Completing the picture. Deducing the rest. So the really crucial point now is taking that overlap of 9 and working backwards. If we know 20 students total play football and 9 of them also play cricket, we just subtract. 20 minus 9 leaves us with 11 students who strictly play only football. No cricket bats for them whatsoever. We do the exact same logic for the cricket side. 18 total cricket players minus the 9 who also play football gives us 9 students who are exclusively dedicated to cricket. We have essentially broken apart our overlapping groups into completely distinct, isolated buckets.
Section 6. The final verification, closing the case.
Let's look at the final tally. By breaking the class down into non-overlapping categories, we totally remove any chance of double counting. We have 11 students playing only football. We have our 9 dual sport athletes playing both. We have 9 students playing only cricket. And crucially, based on our very first clue, we have 0 students playing neither. All the puzzle pieces are finally out on the table, organized perfectly.
And this brilliantly illustrates exactly why the math works. Notice how those 3 distinct segments, 11 plus 9 plus 9, add up perfectly to 29. There are no missing students anymore. There are no phantom students created by double counting. By recognizing that the both category inherently exists inside the individual sport totals, we completely resolve the paradox. The math is absolutely, undeniably flawless.
So, we've cracked the case of the 29 students. But I want to leave you with a thought before we go. This isn't just about football and cricket. This specific type of logic applies to so much more. Think about project management, overlapping resources, or trying to schedule a meeting across different time zones and availabilities, or even just filtering search results online. Whenever you have seemingly contradictory totals, there is usually a hidden overlap just waiting to be isolated. So where else in your daily life can this visual logic map out a solution for you? Keep your eyes open for those hidden intersections. Thanks for joining me on this explainer, and keep learning.